Good morning, class.
Hi.
Okay, so we're moving on. We are now talking about Triangle Sum Theorem today. So you've already had the chance to draw some of these in your notes because we're reading and drawing, okay? We have a triangle here, and the Triangle Sum Theorem basically says that all three angles of a triangle add up to 180 degrees. So I'd like you to put 180 inside of that triangle, and I want you to know that it's usually the case, unless you have an isosceles triangle, okay, that all three angles are different. So you're going to see these congruency markings showing you that each of those triangles are different unless you have an isosceles triangle. So please draw this as I'm drawing it, okay? And the reason why we know it's isosceles is because isosceles triangles have two congruent sides, and they also have two congruent bases, okay? And then an equilateral triangle, go ahead and draw this, okay? An equilateral triangle has all three congruent sides and all three congruent angles. And since we know that all three angles add up to 180 degrees, when you divide it by 3, you get 60, 60, and 60. So please make sure you write that in your notes as well. Okay? So, okay, I'm recording. Okay, so the humming and rapping. Okay, so now guys, I want you to go, we already drew this, okay? And the reason why I put this up here is because we are dealing with the Triangle Sum Theorem, where all three angles interior, so let's write interior, okay? All three interior angles add up to 180 degrees. But when you have a line such as line PR, okay, they are also showing you, which we're going to talk about down here, that there are also exterior angles, okay, that we are dealing with, okay? So what you need to know is that angle 2 is interior, okay, and angle 1 and angle 3 are exterior, and since we have a line here, okay, which is parallel to line segment AC in the triangle, okay, we can see where's Waldo again, okay? So if we extend, so if I'm doing this up here, you're doing this in your notes, okay? And then extend, right? We've got our two parallel lines now cut by a transversal. And so, say supposing if I were to tell you that angle 2 is 40 degrees, okay? You know, we would be able to, if I told you that angle A was 60 degrees, this is just, you know, pretend, okay? We would be able to find the measure of angle C, okay? And then we would also be able to find the measure of angles 1 and 3, okay? So we know that 40 and 60 are already accounted for, right? So 40 plus 60 is 100. So then what's the measure of angle C if all three add up to 180? What's the measure of angle C? 80, okay? So angle C is 80. So, but look here. You need to see, okay, since we created that where's Waldo, you can also see that angle A and angle 1 are alternate interior angles, right? So if A is 60, then what is the measure of angle 1? 60, because alternate, go ahead and put 60, because alternate interior angles. Once again, guys, I'm going to bring it up every time, okay? We are what? Using the clues, okay? That we know. We know what clues to use. And so if we have 60 and 40 here, then what's the measure of angle 3? How do we use the clues to figure out what the measure of angle 3 is? Well, from here all the way to here is 180 degrees, right? Even though 60 is exterior outside of the triangle and 40 is interior inside the triangle, what would the measure of angle 3 be? 80. But look, guys, I'm going to get the black marker. That makes sense because watch. If we draw the other transversal here, right? Right there, right? And we know that this angle here is 80 degrees. Well, then this is also going to be 80 degrees because those are also alternate interior angles. So we've made a mess up here, but if you follow me, we're adding triangles now to everything that we know about angles and supplementary, complementary, okay? Even if, and I forgot to add in here, go ahead and also draw this. Draw a 90, that's a right triangle, okay? A right triangle is a special triangle because it has a 90-degree angle in it, so please draw this, okay? So, and we know the Pythagorean Theorem, a squared plus b squared equals c squared, where this is your hypotenuse. Write this down, okay? Kind of going off topic, but it's very helpful. If this is 90 degrees, then you know that these two angles have to add up to 90 degrees, and that's very helpful for the assignment that we're doing today, okay? So this is, you can write right triangle, okay? That's what it's called. So let's look at our example here, okay? Well, actually, before we look at the example, I want you to look at these three examples here, okay? We have, like I just said, interior and exterior angles. Let's look at this middle one here. You can see that angle 1 is here on the outside of the triangle. And they've labeled angle 2 and 3 on the inside of the triangle. What you need to know is that angle 2 and angle 3 are called remote interior angles. So please draw this and make sure you write remote interior angles. Angle 2 and angle 3 are remote interior angles, okay? And what you need to know about them is that angle 2 plus angle 3 equals the measure of angle 1, the exterior angle here, okay? So angle 2 plus angle 3 equals the measure of angle 1. So remote interior angles, and that's going to help you when you're doing your assignment. Angle 2 plus angle 3 equals the measure of the exterior angle out here. But the remote interior angles can't be like right here. They cannot be here. No. Okay? They cannot be right next to that exterior angle. It cannot. In order for them to be remote interior, it has to be on the opposite side of the triangle and not right next to that exterior angle. So as you can see, you have to be able to look at this in a rotation. These are rotated. They're exactly the same, but they're rotated, right? So here's our exterior angle number 1, and here's our 2 remote interior, but it's still the same thing. Angle 2 plus angle 3 equals the measure of angle 1 outside that exterior angle. So let's take a look at, and we're going to need calculator help here. Let's take a quick look at, actually we'll come back to this and do that together live in class. I just want to make sure that I get to everything in the video. So yeah, and that's basically it. We're going to do examples, but it couldn't hurt to get this example in the video, okay? So guys, we've got all the information that we need, and we have to fill in knowing that all 3 angles of a triangle add up to 180 degrees. We need to figure out what's the measure of angle X, what's the measure of angle Y, and what's the measure of angle Z. So let me first ask you, how many triangles are in this figure?
2.
2?
1.
1. How many triangles are in the figure? We've got 2, and then someone else said 1. Does anyone have any other ideas? Yes, Jeremiah, 3. Okay, we have triangle ABD, we have triangle BCD, and then we have triangle ABC, the large, okay? So let's remember that we can see 3 triangles here. But when we're trying to find the measure of angle X, what would be the easiest way to find the measure of angle X? This angle A is labeled 59, right? This angle B right here, this small angle right here, is labeled 43. So how would we find, knowing that all 3 angles add up to 180 degrees, how do we find the measure of the little angle X? Okay, so 43 plus 59 gives you, I don't know, what is it?
102.
102?
Yeah.
Okay, so then 180 minus 102 gives you 78. So if X is 78, then what is Y? And how do you know?
It'll be 78.
From here all the way to here is 180 degrees. These are adjacent and they form a linear pair and they're a straight angle. So from here all the way to here is 180. So how do we find this angle Y here? 180 minus 78 gives you
102.
102. Okay, now, how do we find the measure of angle Z? It's step-by-step process of elimination. So we know this is 102. We know this little angle here is 49. So how do we get the measure of angle Z?
You add 102 to 49 and you take.
So what's 102 plus 49? Is that 152?
151.
151. So 180 minus 151 is
29.
29 degrees. Okay, so that's our lesson for today.